Hello, everyone, and welcome to today's Saratech Enablement session. My name is Andrea Hall, and I'm the Customer Relationship Manager at Saratech, and I'll be your host today. Presenting today, we are lucky enough to have Isabel Sanz from HP. She is a technical consultant. We are very good partners with HP, and she is going to really be covering an awesome topic here, how to expand your 3D applications through post-processing. If you haven't joined us before for a customer enablement session, we run about 30 minutes each. They are all recorded. We meet here twice a month. And we do post all of our recordings to our YouTube channel, so make sure that you check out all of our past sessions there. Like I said, we meet here twice a month just to learn about new tips, tricks, and old features that will just help you in your everyday tasks. Again, if you haven't joined us before, you may not know that this is an open forum. So if you have any questions or comments during the presentation, you can type them into the questions box on the right-hand side of your GoToWebinar panel there. And I will kindly interrupt Isabel and just let her know about what your comments and questions are. If you'd rather wait until the end and type those into the survey that pops up after the session, you are more than welcome to do that as well. And with that, I am going to pass the baton right over to Isabel.
Okay, perfect. So thank you, Andrea, and thank you everyone connected for taking the time to attend this webinar. As Andrea said, I'm Isabel Sanz, a 3D applications engineer working from HP. And today I'd like to share with you some post-processing options that could enable new applications for your customers. The final look and feel of the parts will depend on the customer requirements, and it would be the same if it's, for example, an interior part or a cosmetic cover. So today we will look into the different options to achieve these different applications. In this session, I will cover how to clean multi-jet fusion parts, and we will compare the different options in terms of their advantages and disadvantages. Yeah, moreover, I will explain how to post-process the multi-jet fusion parts depending on the desired property that is trying to be achieved. And for that purpose, I will focus in 4 different areas: how to get part coloring, color uniformity, surface roughness, and dimensions. And at the same time, I will provide some tips and tricks for each of the post-processes based on the knowledge that we have gathered during the last years with our internal testing and from customers that are using multi-jet fusion today. But before I start to deep dive in all these topics, I'd like to tell you a story about Henry Ford. So in 1909, he announced that Ford was going to build a car, the Model T. And at that point, he claimed, any customer can have a car painted any color that he wants, as long as it is black. So the Model T was a huge success, but just as soon as the product started to become popular, people started to ask for additional colors. Maybe it's just human nature, but people like options and things that speak to their personal style. This story is part of the beginning of the mass production, and we are currently seeing a mega trend where the manufacturing industry is moving from mass production to mass customization and personalization, where each individual customer can get what they want and almost everything is able to be personalized. So this is a whole new world, and now the customer is in charge. So this personalization can come from the design, but not only from there, but also from using different textures or different colors in the final parts. So there are different types of final finishings required depending on the application. As I said before, so for example, a bracket inside an industrial machine will have different requirements compared to exterior cover that is part of a consumer good product. So in the following 20 minutes, I will show you all these different examples of end-to-end solutions that could fulfill those application requirements. Okay, so before that, I would like to frame the objective of this webinar. So here you can see the 3D printing workflow for the 4200 from the loading of the build unit in the processing station through the printing process and the cooling and unpacking afterwards. But today we are going to be focused in the post-processing steps. where you can see that there are two main phases. The first one is the cleaning of the parts, and the secondary post-processing that could be applied afterwards. So the cleaning is a mandatory step where the excess of powder after the part is unpacked is removed. And then after the cleaning of the parts, there are secondary post-processes that could be applied in case there's an additional requirement from the customer, but all of these are optionals. And now let's start on how to clean the parts. As you all may know, when you unpack a part, there's still some powder that is attached to it. So then to completely remove it, so there are different options that could be applied. The most common cleaning option is the bead blasting, which is the HP recommended process for general purposes. However, there is also the possibility of cleaning the parts using water jet blasting. In this case, instead of using compressed air, there are cabinets that use pressurized water instead. And this option could be useful to clean, for example, ducts with complex or intricate geometries, as the pressurized water will have more power to arrive to the excess of powder remaining inside those ducts. And another use case where the water jet blasting could be interesting is in applications where it's mandatory to assure the complete removal of the powder, like, for example, in some medical applications. And now, let's go into the details on how the bead blasting process is done. So first of all, there are two main types of bead blasting cabinets, the manual and the automatic ones. The manual bead blasters have a gun with compressed air that an operator needs to move around the part to clean it. While in the automatic equipment, that is the one that you see on the bottom of the slide, there is a drum where the parts are placed and the drum is rotating. In this case, the gun with the compressed air and the abrasive is fixed, so there is no operator required for the cleaning. The operator should just load and unload the parts inside the equipment. The workflow is very simple in both cases. The main difference between them is that the automatic bead blasting process is less dependent on the operator than the manual one. In the manual blasting, the operator can spend from 1 to around 10 minutes to clean each of the parts, and it has to be done part to part, and the time it takes, it will depend on the size and the complexity of the MJF parts. But with the automatic blasting, the operator could do a batch of parts, for example, around 50 parts, but it will also depend it will depend on the size and the complexity, and the time it takes to clean one of these batches is 20 minutes. And it will only require around 10 minutes of the operator time, just by doing the loading and the unloading of the parts inside the cabinet. Moreover, in the automatic bead blasting, as it is an automated process, you can prevent variability in the cleaning of the parts. So for this reason, if you want to produce final parts, it is recommended to use an automatic blasting to ensure this consistency in the surface finish. When bead blasting, there are small particles of powder that become attached to the part due to static electricity. So then in order to remove them, there are two possible options that could be done. The first one is to air blast the parts, as you can see in the slide, after the cleaning in a separate cabin to remove these remaining particles. And on the other hand, there are also some bead blasters that use ionized air, which avoids the static electricity problem of the powder attached to the part. So therefore, there is no powder that it's attached during the cleaning process, so this air blasting step could be totally removed. And then on the other hand, for fragile parts, like for example, part with small features or small pins, we recommend using the manual bead blasting because the details could be better preserved. And for big and thin parts or parts that will tend to warp, we will also recommend to use the manual bead blasting, because those type of parts could be damaged in the automatic bead blasting. Then we have tested several abrasives that could be used for in these bead blasting cabinets for the multi-jet fusion parts. So the most recommended abrasive that we have at this moment are the glass beads. So the glass beads have a lower cost compared to other abrasives in the market and can get a very good surface finish. But then on the other hand, there are some metallic abrasives, such as stainless steel, for example, that could improve and give a better color uniformity than the glass bead. In this case, those metallic abrasives are more aggressive. So the time to clean the part is reduced, but at the same time, they are providing a better surface finish. So this could be an interesting option to use in parts that don't have any small details that could be damaged with the abrasive. And then the particle size that we recommend for the bead blaster, for the glass bead, sorry, it's a particle size from 70 to 110 microns, because this is the size that will maximize the powder removal and the duration of the abrasive in the cabinet. Then, on the other hand, the soot pinning, it could also apply after dyeing the parts in a bead blasting cabinet, because this process and it's reducing the scratchability of these dye parts. In this case, the material used is a ceramic or plastic abrasive, and the particle size is bigger than in the case of the glass beads. And both of them could be used to improve the surface roughness by blasting the parts for a longer period of time. So if the parts are blasted for 20 minutes, the surface roughness could be reduced more than with the standard operation. Okay, so now let's take a look into the secondary post-processing options. As I said before, after cleaning the parts, there are further post-processes that could be applied depending on the desired quality or the finishing of the final part. So there are different post-processes that we could choose from. For this presentation, I have classified all these options depending on what the customer is trying to achieve. So the post processes are organized depending on if they are able to produce or achieve color uniformity, coloring the parts, improving the surface roughness, the dimensional properties, or even other properties such as the conductivity or the temperature resistance of the material. But in today's webinar, as you can see, the list is very long, so I will be able to cover only the options that are highlighted in black. But if there's anyone that needs additional information for any of the other post processes, then yeah, we could get in contact through Andrea to provide you that information. So now we will start with the color uniformity. So the first process that we are going to talk about is the dyeing process. And in this one, there are pigments used that are penetrating through the surface of the part. So it's helping to provide a uniform color, but at the same time, it's very robust in terms of scratches because it's penetrating through the part. So this is how a dyed part will look like. And by the way, at this point, I would like to comment that all the post processes I'm going to talk about are based on the multi-jet fusion parts that are coming from the 4200 platform. But I will give as well some hints or tips for the 500 series platform, because in the 4200 platform, we are able to produce parts that are gray, while in the 500 series, the customers will be able to print parts that are white or full color parts. So the post processes may be slightly different. But for example, in the case of the dye, this is an operation that could be performed in the 540 platform because it has white parts, but also in the 4200, as we will see in a few minutes. So then the dyeing is a process that is recommended for consumer parts because it's providing this homogeneous look and feel, but it could be also used, for example, in prosthetics, because in this case, the color wear resistance, it will be a requirement. So how can we dye the parts? So the first option is to do a manual dyeing. The manual dyeing is a very simple and inexpensive process where you would only need to place the parts in a hot bath with dye pigments at around 80 degrees Celsius. So during this bath, the dye will reach all the parts and it will go inside all the geometry because it's not geometry dependent as easy as it is penetrating inside the surface.
Hi,
So then,
Isabel. We actually have a
yeah,
question.
okay, perfect.
Shane wants to know, in a full color machine like the 580, is there a way to post-process the full color?
Yeah, there are options to post-process the full color. So, for example, dye is not a thing that it would be suitable for that one because it already has the color. But you could apply, for example, coatings on top of that, or you could do a chemical polishing. Actually, I'm going to cover some of those post-processes afterwards. But yeah,
Okay,
and
and
then
he
we can review it.
actually just wrote back and said, how about to enhance the color? Is there a way to enhance it?
Yeah, for example, through coatings. So there are a varnish could be applied, for example, or a wax on top of the part, and all those are going to enhance the color and get more vivid colors. Or the chemical polishing, it could be another option as well, where there's you can get glossier parts.
Okay.
Okay, good, perfect. So then after the parts are dyed, there's a very important step as well that we recommend that is using a post bath with water that is between 50 to 80 degrees Celsius of temperature, because with this post bath we are preventing to have warpaths on the final parts. And then to do this manual dyeing, it could be used a pot, as you can see on the slide, or an electric fryer. And then if you have tried this process, or then you can imagine, or you may have experienced already, that this manual dyeing is something that can be messy and very time consuming for the operators. So it's not really scalable or suitable for production, but it could work for small quantities of dyed parts. But then, in order to address those issues and get a system that is more scalable to production, there's a company that is called Girbau that introduced a new system that is called the DY130. So this equipment is designed by this manufacturer that is a manufacturer of industrial equipment and provides an attended process without the need of any working pressure or water osmosis that may be required in other available equipment in the market. In this system, there's also an integrated recycle time that allows to recycle the dyeing mix up to from 5 to 10 times depending on the dyeing selected. And it's also an open platform, which means that customers can develop their own dyeing profiles with different temperatures and different times to adapt the process, for example, to a specific material or to get a specific product. So this is a batch process, and the cycle time is around 2 hours, but it's a solution that it could be very interesting for customers that really want to do this process for manufacturing, because it's going to give better repeatability and homogeneity than the manual dyeing. Then as pigments to dye the parts, HP recommend two different options. On the left side of the slide, there is a French company that is providing specific dyes for the 3D printing industry that is called TCN. So these dyes are supplied in liquid state, and they have several colors that you could choose from. And then on the other hand, that is the one on the right of the slide, there is another option that is widely available in the market, which are the reed dyes. So the recommended product to use from the reed company is the Proline series, the one that you can see in the slide, because this is the one that we have proof that is given that is giving the best color homogeneity. These dyes, the red dyes, are coming from the textile industry, but as multi-jet fusion is printing with nylon, they can be used to color our parts as well. And then now I would like to give you another important tip for the dyed parts. So it is very common that some stains or scratches appear after dyeing the parts, like the ones that you see highlighted in the part in the slide with red arrows. So in this case, the soot pinning post-process is recommended because it will be able to remove these slides. So in this graph, we have quantified the different types of stains that appear in the part that you have already seen in the slide. So on the left side, you can see the different type of stains that appear on that one. And after that, we have applied the soot pinning process. So on the right side, you can see that all the previous stains were removed, and then we got a good part. And this is the final look and feel. So then, as you can see, applying this second treatment of soot pinning after dyeing, it's very effective because it's mitigating the stain and it's also removing the part scratches. This process can be done in the automatic or the manual bead blaster, and we would recommend to have a separate cabinet to perform this one because the abrasives that are used may be different. And then there's another additional option that could be used for removing the stains from the dyed parts, that is using a heat gun with a low power. But here customers have to be careful because if the heat gun is too close to the part could be damaged. But it's another potential option that could be used. So then if we move into another post-process that is used to improve the color uniformity, we have the graphite blasting. So the graphite blasting is able to provide a metallic look and feel as the one you can see in the slide. So then this post-process is recommended for applications where there's interesting to have a certain level of lubrication because the graphite is a natural lubrication. So one option could be in gears, for example, or it could be also used in visual prototypes where this look and feel is interesting. Here, it's important to clarify that it's not recommended to be used in parts that are going to be handled in a regular basis for the customer, because it's not wear resistant and it will fade over time. The graphite particles are placed in the porosity that is on top of the surface, but there is no further attachment to the final part. So that's why at the end, this graphite wears out and fades away. And if we look into the workflow, so the graphite blasting is a process that is very similar to the bead blasting. And therefore, you can process your parts in a manual or an automatic bead blasting cabinet. The way to introduce the graphite is to mix it together with the glass beads and load it as in a normal bead blasting process. In this case, we recommend to have a separate cabinet for the graphite because the replacement of the beads mixed with the graphite is something that is going to be done more often than in the standard bead blasting. And it's important to clarify as well that this post-process is not affecting the dimensional or mechanical properties, but it may have other advantages such as the increase of the lubricity. Then if we move into the coloring, there are two main post processes that could be done in this case. That will be painting the parts or dyeing the parts. So in this case, I would like to clarify that in the 580 printer, the parts could be directly printed in color. So this will be a case where these post processes are not necessary. So the paint can be applied to the multi-jet fusing parts using various methods. So depending on the final part quality requirements, it is possible to directly paint the raw part, or we could apply first a primer, as you can see on this part over here, and use a manual sanding in order to achieve a smoother surface finish when the paint is applied on top. So the painting is a process that could be used in consumer goods, in a final part production of automotive parts, for example, and here it could be very relevant, a color matching between the 3D printed parts together with injection molded parts. So the way to do this color matching between them will be to apply a paint on both of them, or in visual models for prototyping purposes. If we take a look into the process, multi-jet fusion parts can be painted using the conventional processes that the customer may already have available. So for example, for model shops that are already painting, they could use their existing equipment to paint the 3D printed parts. And depending on the desired finish, as I said before, there are different steps that could be followed. So for parts that have cosmetic requirements and have to be very smooth, it is required to apply first a primer that has to be dry, and then afterwards it can be manually polished by using sandpaper. This could be repeated several times after the desired level of smoothness is required, and then once the surface is already smooth, the layers of paint can be applied on top. And depending on the color of the paint, one or more layers may be required. Afterwards, there are coatings that could be applied as well on top, such as a varnish to get a glossy finish. And this type of varnish, it could be the same one that could be used in the 580 printer to enhance the colors. So in terms of advantages, one of the things is multi-jet fusion parts can be painted in all colors in every type of platform that we have available for white or gray parts. And water-based or solvent paints can be applied. This is a process that has a collateral effect as well, that it could be used to improve the surface roughness, and through additional coatings that could be placed on top or in the same paint, there are other properties that can be achieved, such as the UV resistance of the color, having a scratch resistance, or getting a glossier part. Then another point to highlight is that even for the gray parts from the 4200, those parts could be dyed in colors, as you can see. But as we are coming from a background that is gray, then the colors that could be achieved through the dye process are dark colors. So we could not get a light blue, for example. But if the customer is using the 540 series, as the parts are white, the parts can be dyed in all different colors. So this could be an interesting option to consider for outdoor applications, where, for example, the UV resistance is required. So there are dyes available in the market that can resist the UV light without fading. So now let's review the options to improve the surface roughness of the part. The vibratory finishing, that is also known as tumbling, it's an option that can significantly improve the smoothness of the multi-jet fusion parts. So due to the 3D printing process, surface roughness is not consistent among all the part surfaces. So then, for example, through the tumbling, we can get a more homogeneous roughness all around the part. And this option could be interesting, for example, in consumer goods or in tubes or pipes where the smoothness of the part is something relevant, for example, to get a proper laminar flow. In this post-process, depending on what surface finish you need, there are three main variables that have to be considered. That are the time, the revolutions per minute of the equipment, and the abrasive use. So in this graph, you can see that there are different surface roughness or RA values that can be achieved with the tumbling. The measured surface parameter, the RA, that is the average surface roughness, it's inversely proportional to how smooth the part surface is. And depending on the abrasive use, the outcome of the part can be different. So, for example, we know that, as you can see in the graph, that the plastic abrasive is less aggressive than the ceramic one. So it could be interesting to use it for parts where it could be interesting to use where parts where there are details and we don't want to remove those details through the tumbler, while in other parts where there's only a raw surface without any type of texture, the ceramic abrasive will be the one that is providing the best productivity because it can get under a very low RA or a very smooth part with a shorter period of time. So here you can see which is the workflow that could be used in a vibratory finishing or a tumbler. This is a semi-automated process that it requires a little operator time, and actually the operator has only needs to place the parts inside the tumbler and remove them afterwards. Then, as you have seen in the previous slide, the time that it takes the part to be smoothened inside the tumbler will depend on the abrasive, but also on the final requirement. And this is something that could take between 3 to up to 24 hours. And then a last option that could be used to improve the surface roughness is to paint the parts, because just by adding additional layers of paint, the surface roughness can be minimized. And in this case, if the RA requirement is even lower than the levels that you can see in the slide, there could be used the primer, as I was explaining in the previous section. And as the last part of my presentation, there are other smoothening options that could be used. There's another very interesting option that is a chemical polishing. And here, instead of using the friction between the abrasive of the part and using the friction between the abrasive and the part to remove this excess of material and get a surface that is smooth, there's a chemical that is attacking the surface of the nylon and it's melting that surface. So this is applied inside of the equipment that have a vapor with this chemical, and it's a batch process that it may take around 2 hours. And then another option is electroplating the parts. So to get a smooth surface, the part could be directly electroplated, or we could use a primer in between to have the electroplating afterwards to put it on top of that one. Okay, good. So yeah, this is the last slide that I have for of my presentation. So now we could open some time for any questions that the attendees may have.
Okay, looks like we got another question from Shane. What chemical is used in the chemical polishing?
Yeah, that's a great question. So it's a hexafluoroethanol, if I remember correctly, but I could provide the details and the data sheet for that one. Here, one important thing is that, for example, in the FDM parts, it's acetone could be used in order to polish them because the ABS is easily attacked from different chemicals. But in the case of the nylons are very resistant to several chemicals, and actually this is an advantage in most of the cases, because that means that we can work with different fluids without having a chemical attack. But then for this chemical polishing, we need to have a chemical, let's say, that is not so easy to handle, such as an acetone, for example. So it has to be, it's a corrosive one, but it's enclosed in a compacted system.
Okay, Benjamin wants to know, do the parts swell and warp any when we put them in the hot dye buckets? If so, what can we do to avoid it?
Yeah, that's another great question. So when we are dyeing the parts, as we are using a nylon 12, So you may know that the nylon family, it's a hygroscopic family. So all of those are hygroscopic materials. Then inside the nylons family, there are different levels. So one of the ones that absorbs the most quantity of water is the nylon 6. But still in the nylon 12, we can have a water absorption that is around, and depending on the geometry, it can go from 0.5% up to 5, 6, 7%. So when we are dyeing the parts, what we are doing is that we are saturating the material, but for a short period of time. So the parts are swelling, we have quantified that. The increase in the dimensions is around 50 to 100 microns, but again, it will depend on the surface quality, on the size of and the geometry of the part. So one of the options that could be done is to scale down the parts to absorb that swollen that is going to happen afterwards.
Okay, awesome. And for any of you that ask questions or anyone that is not comfortable asking their question right now, like I said, we will be sending out the recording to this, so you can ask further questions just by replying to that email when we send the recording, or you can put it in the survey that's going to pop up in just a couple of minutes. But Isabel, it looks like that is all of our questions for today. Thank you so much for presenting. You did a great job. Like I said, this will be posted to YouTube. Make sure that you subscribe to our YouTube channel, the Saratech YouTube channel. That way you get a little notification every time we post these awesome videos. We do lots of shorter videos as well. So of course, this one is going to be close to about 30 minutes, but we do videos that are just a couple of minutes long as well, just to give you quick little tips and tricks on lots of different things. And don't forget to stick around for just about 20 or 30 seconds after we end the session and just let us know how we did today and if you have any suggestions for future sessions. And Isabel, thank you again so much.
Okay, perfect. Thank you very much. And yeah, just to do a last comment. So if there's anyone that wants to get more detailed information about any of these post processes, we have white papers available that we could provide to them. So they have the details on how to proceed for each of those.
That would be so helpful. That's awesome. And I know one person asked, are you able to provide the slides from the presentation today to the attendees, or is that not allowed?
Sure. No, I think we can do it. Yep.
Okay, wonderful. So Lawrence, there's your questions for that, your answer for that, and we'll be sure to send that out to you, Lawrence. And if anyone else needs that, just let us know. And you all have a wonderful Thursday. We hope to see you again for our next session.